Automated vulnerability scans generate thousands of findings. But here's the problem. How do you know which ones are actually critical and which ones are just noise? Traditional scanners can't tell. AI can. Today I'm going to show you how automated vulnerability scanning with AI changes the game. Disclaimer. This video is for educational purposes only. Do not test or attack systems you don't own or have permission for. Today we're going to explore processes that you can follow to test invulnerability. Honestly, bug bounty programs are becoming increasingly advanced, making it harder for beginners to find bugs. So simply running tools won't work it. You need to invest time, effort, and patience. Often you won't find a vulnerability on your first try. Don't get stuck on just one process. If one way doesn't work, try another. The testing process will constantly evolve, sometimes manual, sometimes automated, and sometimes logic-based. As you regularly hunt for bugs, you'll gradually understand where and how to test. The most important thing is to keep practicing and don't get discouraged. Bug bounty is not a sprint, it's a long-term game. On these websites, you can find bug bounty programs where bug bounty hunters actively work. Within the defined scope, if they find a valid bug, they submit a report. After submission, the team reviews the report. If the bug is valid, they reward the hunter with a bounty. And if someone has already reported the same issue before you, it will be marked as a duplicate. Even then, most programs will still encourage you to keep working and improving. Today, I'll demonstrate everything on a demo test website, how to test properly, and what the process looks like. For learning purposes, you should follow the same process. As you keep learning and practicing, you'll gradually understand where to test and what type of testing is needed. You won't learn everything in a single day. Just keep learning, keep practicing, and stay consistent. If you do that, you will succeed. All demonstrations in this video are performed on testphp.vulnweb.com, a deliberately vulnerable website created for learning and testing. Vulnerability assessment means identifying security weaknesses in a system or website before attackers do. These weaknesses can exist at the network level, the web application level, or the system level. Vulnerabilities are discovered through automated scanning and manual testing. For automated scanning, tools like Nessus, OpenVAS, and Nuclei are commonly used. The main goal is simple: to reduce security risks and make the system safer. Vulnerability management is a structured process that can be divided into three main phases. Each step in this life cycle ensures a systematic approach, so security risks are consistently managed and our systems stay safe at all times. Vulnerability research is the process of discovering new security weaknesses. Researchers use manual testing, code review, exploit testing, and trusted databases like MSRC, ExploitDB, and dark reading to identify vulnerabilities, understand their severity, and make systems safer. This process is crucial for bug bounty programs, penetration testing, and enterprise security planning. Before manually hunting for vulnerabilities, use Katana tools. Katana-target-file name. First step is to extract all the URLs inside the target website, including the ones that don't normally show up at first glance. To remove duplicate URLs, we use the sort -u command. It takes the file we saved earlier and removes all duplicate URLs, then saves the result into a new file. This way, the same endpoint doesn't appear again and again. The result is a clean attack surface, which makes manual testing much more efficient. Separate parameterized URLs. We use this command: grep equals clean.txt greater than params.txt. These URLs are the most important ones to check for vulnerabilities like XSS, SQL injection, LFI, and SSRF. That's why parameterized URLs are considered high-value targets for manual testing. When we run a full scan with Nuclei, this is the command we use: nuclei-l params.txt. Here's what this command is doing. Nuclei is the vulnerability scanner. -l params.txt tells Nuclei to take targets from a list of URLs. It scans those URLs using default Nuclei templates. So, what does Nuclei check by default? Cross-site scripting, XSS, SQL injection, local file inclusion, LFI, open redirects, security misconfigurations. In short, This command helps us perform automated vulnerability detection on high-value targets. Automated vulnerability scanning tools. Among automated scanning tools, we'll start with Nuclei. Nuclei-u target URL. This is the basic scan command. The purpose of this command is to check whether a single URL has any known vulnerabilities. Here's what Nuclei does in a basic scan. Scans only the homepage, checks using predefined templates, looks for known vulnerability patterns, and here's what it does not do. Does not crawl the website, it does not discover parameters. So this type of scan is useful for a quick initial vulnerability check, not deep testing. To scan individual parameterized URLs collected using Katana, we use Nuclei like this: Nuclei-u parameterized URL. This command tells Nuclei to scan one specific parameter-based URL for known vulnerabilities. This is useful when you want to test high-value URLs individually instead of scanning the entire list at once, especially for issues like XSS, SQL injection, LFI, and open redirects. This command checks a specific URL with parameters contains any known vulnerabilities. Command cheat sheet for using Nuclei in bug hunting. Among all of these, parameter-based scanning is the most commonly used, and that's why I showed it right at the beginning. High chance of XSS, SQLI, LFI vulnerabilities. I've also included a few more commands here, specifically for XSS, SQLI injection, and LFI path traversal testing. SSRF, open redirect critical and high severity only. CVScan, technology-based scan. Misconfiguration scan, safe scan, WAF friendly. Save output for AI analysis, custom template scan. You can get started using these commands right away. If you practice and learn by following all of these commands, they'll become very useful for you later on in bug hunting. Nikto is used to find web server level issues. The basic command looks like this: Nikto-h target URL. It works with both HTTP and HTTPS targets and helps identify common server misconfigurations and known issues. For a full aggressive scan with Nikto, we use this command: Nikto-h target-c all. So, what can Nikto detect? Here are some common examples. Expose files like phpinfo.php, default admin panels such as /admin, open directories like /testoutdated Apache, or Nginx, versions, missing security headers, basic weak SSL configurations. Nikto focuses on web server level misconfigurations, making it very useful for quick reconnaissance and initial security checks. Compared to SGPT, Gemini CLI AI does deeper and more effective analysis. I created a prompt using ChatGPT and then used that prompt with Gemini AI. In the prompt, I clearly instructed Gemini to scan the target URL using Nikto and then analyze the scan results like an experienced penetration tester. The AI separates real vulnerabilities from false positives, explains each important issue in simple language, including the impact, possible attack scenarios, and manual verification steps. It also clearly identifies which findings are report-worthy, which ones are informational and which can be safely ignored. Same process for Nuclei analysis by using an AI prompt in Gemini CLI. In that prompt, I instructed the AI to scan the target using Nuclei and then analyze the results. AI separates real, exploitable vulnerabilities, false positives, and informational findings. It explains each important issue in simple language, including the impact, possible exploitation, and manual verification steps. It also assigns proper severity levels and clearly states which findings are worth reporting in bug bounty programs, which ones require further verification, and which ones can be safely ignored. After getting this analysis, it becomes much easier to understand what kind of vulnerability it is and how serious the impact can be. This is especially helpful for beginners because many people struggle to understand how a vulnerability actually works and what damage it can cause. Using AI for analysis makes the entire process simpler, clearer, and more efficient. You can also perform automated vulnerability scanning using Sniper. You can install Sniper directly from GitHub and you'll find all the usage commands there. By following those commands, you can start testing step by step. Sniper works as a framework that integrates many security tools into one place. So instead of installing multiple tools separately and running different commands for each one, Sniper can be a good all-in-one option, especially for beginners. Make sure to install and run this tool as the root user. Sniper is an automated reconnaissance tool mainly used at the beginning of bug hunting or penetration testing to quickly map out a target's attack surface. It doesn't perform deep vulnerability exploitation by itself. Instead, it runs multiple security tools together, such as Nmap, Nikto, WhatWeb, DeerSearch, and GoBuster. This means you don't have to run each tool separately, which saves a lot of time. Sniper typically provides initial reconnaissance information like which ports are open, which web services are running, whether there are any basic misconfigurations. In bug bounty and penetration testing, Sniper is most useful during the recon stage, where the goal is to get a high-level understanding of the target. However, Sniper is not a replacement for tools like Nuclei or Burp Suite. The output from Sniper should be validated later using Nuclei, manual testing, and AI-based analysis to confirm real vulnerabilities. Osmedeus is an advanced automated reconnaissance and vulnerability hunting framework designed mainly for bug bounty hunters and penetration testers. Its goal is to automate the entire bug hunting workflow, not just recon, but also initial vulnerability detection. Instead of running tools one by one, Osmedeus follows a structured workflow to map the full attack surface efficiently. However, Osmedeus does not make final decisions. It can generate false positives, so best practice is use Osmedeus for recon and initial scanning, then verify findings with Nuclei and manual testing, and finally confirm real exploitable vulnerabilities using AI or your own analysis. ReconFTW is an automated reconnaissance framework commonly used by ethical hackers, bug bounty hunters, and penetration testers. Its purpose is to collect, organize, and map as much information as possible about a target, such as a website, IP, or domain, before exploitation. ReconFTW is an automated reconnaissance framework commonly used by ethical hackers, bug bounty hunters, and penetration testers. Its purpose is to collect, organize, and map as much information as possible about a target, such as a website, IP, or domain, before exploitation. Automated reconnaissance, ReconFTW, automatically runs multiple recon tools, including subdomain enumeration, port scanning, and service detection. Information gathering. It collects details like DNS records, open ports, technologies in use, and potential vulnerabilities. Efficiency. By combining many tools into a single workflow, ReconFTW provides faster and more structured results compared to manual reconnaissance. Bug bounty support. For bug bounty hunters, ReconFTW is especially useful because it helps filter high-value findings and map the attack surface effectively. In short, ReconFTW is an all-in-one automated recon tool that helps hackers and testers gather accurate information about a target quickly, making the next steps of vulnerability assessment much easier. Never rely completely on automated tools. Always manually test the findings or use AI-based analysis to understand how serious a bug actually is. WPScan is a very effective tool for finding vulnerabilities in WordPress websites. It's mainly used for initial vulnerability assessment. With WPScan, you can check whether any WordPress plugins have known vulnerabilities. Automated vulnerability scanning and report generation tools. One popular commercial automated vulnerability scanning tool is Acunetix. For automated testing, you just add your target and it will scan automatically and provide a detailed report. Acunetix is primarily a web vulnerability scanner capable of detecting various security issues in web applications. For example, it can find SQL injection, cross-site scripting, XSS, authentication issues, and misconfigurations. Acunetix is mainly used by companies and penetration testing firms, and it's a paid tool that helps organizations strengthen the security of their web applications. Nessus is a popular network and system vulnerability scanner. It's mainly used to identify known CVES, missing patches, and vulnerabilities at the operating system and service level. Nessus is commonly used by SOC teams and blue teams to assess the security posture of their networks and infrastructure. It's a paid tool, but the Nessus Essentials version is available for free with limited scanning capabilities, making it suitable for beginners and small environments. Burp Suite Pro is a powerful web application security tool used to find vulnerabilities in web applications. It can detect a wide range of web vulnerabilities and supports both automated and manual testing, including testing for business logic flaws. Burp Suite Pro is commonly used by penetration testers and bug bounty hunters. It's a paid tool and is extremely popular for advanced web security testing. There is also a free community edition which you can use to perform manual testing. OWASP Zap, also known as Z Attack Proxy, is a web application security testing tool. Its main purpose is to find security vulnerabilities in websites and web applications, especially for bug bounty hunters, penetration testers, and ethical hackers. In simple terms, Zap works as a man-in-the-middle proxy. It sits between your browser and the target website, intercepting and analyzing all requests and responses to identify weaknesses. In one paragraph, OWASP Zap intercepts web application traffic and performs both automated and manual vulnerability scanning. It can detect common web vulnerabilities such as XSS, SQL injection, CSRF, security misconfigurations, and missing security headers. Zap Active Scanner actively attacks the application to discover vulnerabilities, while the passive scanner silently analyzes traffic without sending attacks. Additionally, Zap supports crawling, spidering, fuzzing, API testing, and authentication-based testing, making it extremely useful for bug bounty and real-world penetration testing. Besides these, there are many more automated vulnerability scanners available in the industry. Some popular tools include GFI LandGuard, OpenVAS, Qualys Vulnerability Management, Insight VM, Nexpose, Tripwire IP360, Saint Security Suite, Be Secure, Core Impact Pro, Intruder, Manage Engine Vulnerability Manager Plus, Astra Pentest, Skybox, Max Patrol. And for dynamic application security testing, some notable tools are Rapid7 App Spider, Checkmarx DAST, HCL AppScan, Veracode Dynamic Analysis. Each of these tools is designed for automated vulnerability scanning, and the choice depends on the environment, scope, and security requirements. After performing a vulnerability scan, all we get is the scanner output. To make sense of this output, we use several databases. CVE tells us what the vulnerability actually is. It's just a unique ID so everyone can refer to the same vulnerability by the same name. Next, we check NVD, which provides the severity, CVSS score, attack vector, and impact, helping us understand how dangerous the vulnerability really is. Bugcrowd Vulnerability Rating Taxonomy, or VRT, is an industry standard classification system that rates vulnerabilities based on their priority and severity. Then comes CWE, which explains why the vulnerability exists, basically the category of the weakness, like SQL injection or XSS. Finally, we look at ExploitDB to verify if the vulnerability can actually be exploited in the real world, whether there's a public exploit or proof of concept available. By combining all four of these, we can decide which vulnerabilities are critical, which are low risk, and which ones should be fixed first. After an automated vulnerability scan with Acunetix, it automatically generates a detailed security report. This report lists all detected vulnerabilities in the target web application, organized by severity. For each vulnerability, the report includes issue description, risk, level, affected URL, and parameter details, proof of concept requests, remediation, or fix recommendations. This makes it easy for the security team to understand which vulnerabilities to fix first and how to mitigate them. However, before writing your report in your own style, you must carefully verify each vulnerability yourself. Once you confirm the findings, you can prepare your report. You can also review how Acunetix structures its reports, which is helpful to understand how professional vulnerability reports are presented. If you enjoyed this video, don't forget to like it, subscribe, and stay tuned for the next video. Thanks for watching.